Hi fellow devs. So today we're looking at problem 399, number of recent calls, which is part of the Leet 75 series. So the question reads like, you have a recent counter class, which counts the number of recent requests within a certain time frame. Implement a recent counter class, initialize the counter with 0 recent requests, and then int ping, which takes in time, adds a new request of time t, where t represents some time in milliseconds, and returns the number of requests that has happened in the past 3000 milliseconds, including the new request. Specifically, return the number of requests that have happened in the inclusive range of 3 t minus 3000. It is guaranteed that every call to ping uses strictly larger values of t than the previous call. So let's have a look at this on the whiteboard. So what we know is like t will always be increasing. So if we start with t equals to 1, then the next one we will get is t equals to 2, 3, and so on and so forth, right? Now we have two things that we want to implement. One is the recent counter function, which is basically the class, and then the second one is the ping function of the class, right? Now the question kind of becomes how do we store the pings that are coming in? So remember, we want a way of maintaining order. So we want to make sure that when a t comes in, we're maintaining the order in which it's come in, right? So every time there's a new t, it gets appended to whatever we choose. So if we got t1, then t2, then t3, and then t4, we want to make sure this order is maintained. Although it doesn't say this in the question, but I think it just implies what sort of data structure can we use that will help us maintain the order in which data is passed through. There's two data structures that come to my mind. Actually, there might be three of them. One is a linked list. So this one will maintain the order. So where we have some sort of a node that takes in the data property over here, and then a pointer which points to the next one, and then the next one, and so on and so forth, right? So normally the first one is called the head, and then the last one is usually called the tail, but then depending on our use case, we may or may not choose to maintain our tail, right? The next one that comes to mind is an array, right? Which is basically just a contiguous memory allocation. So we have a certain number of memory slots. So let's say if we have 10 memory slots, so we will have 10 indices. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And then we would have whatever data we want stored in the slots themselves, right? Another one that comes to mind is probably a set. Now, sets in JavaScript are kind of weird, or they have some unique properties. So sets actually maintain the order in which data is inserted as far as JavaScript is concerned. But then there's one part of sets that we probably won't use, which is sets don't allow duplicates, right? And anyway, because our t is always increasing, right? This particular feature doesn't really make much sense. So whether we have it or we don't have it, it really doesn't make much sense. Now, given that we always want to return within a given range, right? That is t minus 3000 till t, right? So a linked list would be good because in the head, we can always see if the head is less than 3000, t minus 3000, right? Then we kind of point the head to the next one. But then the problem usually comes with insertion, because if we don't maintain our tail, then inserting in our linked list would be an of n operation. So we will start at the head, we'll keep on going until we find the tail, and then we will insert into it. Let's look at arrays. So arrays, the insertion is an O of 1 operation, like it's constant time. So all the time, whenever we insert something, we'll be inserting it at the end mostly, right? And once we insert it at the end, that's an O of 1 operation, because we already know where the memory allocation is starting and where it's going to be ending. So we're just inserting it in the last slot. Deleting it is a bit of a different story, because we mostly want to delete from the front of our array, because the front will be the smallest values, right? So every time we delete from the front, we probably have to do some sort of like an unshift operation, which means that after we delete the data, let's put some random data in. So 1 2 3 4 5 6 7 8 9 10 and 11, right? So now we have new data that has come in, which is 11. So inserting it was straightforward. Now deleting 1, on the other hand, would be a bit different. So to delete 1, we would erase this, and then what we would do is we would get the next slot, the data from the next slot, up 1, right? So 2 comes forward, 3 comes forward, 4 comes forward, 5 comes forward, 6 comes forward, 7 comes forward, 8, 9, 10, and then finally 11, and then the last one is blank. So as you can clearly see, like unshifting is more or less an O of n operation, right? With sets, it's also another weird one, because although sets do maintain the order, but then in JavaScript there is no way of directly calling a certain sequence or a certain slot. So a set is normally denoted by round brackets. So if we have data over here, so we have 0, 1, 2, 3, and so on and so forth, we don't really have addresses, right? So we don't have access to the pointers to all of this data. So every time we want to do a delete, we kind of need to loop through the whole set and figure out which one we need to remove, right? So again, just to reiterate, so with the linked list, so let's see, with a linked list, right, we have the add operation and the delete operation, right? So we have linked list, array, and set, right? So the add operation could potentially be an O of n if we don't maintain our tail, right? The delete operation will be since we're just deleting the head, so that will be kind of constant time, so it will be an O of 1 operation. With an array, the add operation will be constant, because we're writing to the end. The delete operation will be an O of n operation. With a set, adding again will be O of 1, and deleting would again be O of n. Now it kind of depends on what our interviewer asks for, or what our question actually asks for. According to this question, we don't really care much about optimizing, since we know that t is going to be between 1 and 10 to the power of 9, right? And at most we have 10 to the power of 4 calls that will be made to ping. Probably the simplest way of doing this would be in an array. Let's head to LeetCode and let's try and code this up. Since we are just using some sort of an array, so we can just declare a constant called requests and just equal it to an empty array. Now every time we are doing a ping, we need to append the ping to the end. So we can do this dot requests and push the value of t. After we've pushed our data in, let's think about how to handle the delete part. It might be possible that ping missed a whole bunch of values. So we might have a scenario such as the one that's in the example, where we have 1 and then 100 and then 3001, 3002, so on and so forth. So in which case we want to get rid of anything that is 3002 minus 3000, right? So in that case, we're just getting rid of one data point or one time, right? It could also be a case where we have 1, then 100, then 3000, then 4000, right? In which case 3000 minus 4000 is 1000. So we want to get rid of anything that's below 1000, right? So we can either choose to keep on doing unshift operations until we see that the first element in our array is within the given window, or we could actually just do a filter. Now, if we are doing a filter, that means that it's an O of n operation, right? But every time we do an unshift, it's an O of n operation. So if we kind of have to do unshift multiple times, we are adding up more and more complexity. I hope that makes sense. So I'm going to opt for doing a filter. So in that case, I will just be doing this dot requests equals to this dot requests dot filter, and filter takes in callback function. So I'm going to call my temp variable rec, and I'm going to return anything with any rec that is greater than or equal to t minus 3000, right? So that should get me all the requests that are within the given range. And then finally, I can just return this dot requests dot length. The dot length, since it's just the property of the array, looking that up is going to be constant time. So we're not really putting in more time on that side. Let's try and run it. Oh, I see. Since this dot request was never declared, so that's why it never got called. Let's see. This dot requests, typo over there, and that works. That works. Awesome. So not the most efficient solution, but it should work. With that, thank you guys so much for watching this video, and I hope you learned something. And thank you so much for giving love to this series. I really appreciate it. I'm going to be continuing to do more and more questions within this series, and I hope to see you guys in the next one. Cheers.